Just a quick bit about me. I've been working with PHP since about 2003. Built a lot of PHP web applications and websites that I've had to scale, which has been fun. I've done some operations work. I've crossed over to the other side and built application infrastructures, where it's kind of where I learned a lot about Devops. I'm an open source enthusiast. What does that mean? I enjoy working with open source software and trying to contribute when I have the time. And I'm a big fan of the DevOps cultural and professional movement, which is what brings me out today. So DevOps. So 2014 was the fifth year anniversary of the idea that DevOps was born. The idea was born because a couple of system administrators came together and they were facing some common challenges and problems at the time. So they decided to organize a conference called DevOps Days, and that was in Antwerp in 2009. And in a lot of ways, DevOps started out as an ideology. It's the set of ideas and beliefs of a group. And these set of ideas have sort of gained a lot of traction, because a lot of people have heard of this term DevOps. But in a lot of ways, it's caused a lot of complaints and confusion about what DevOps actually is. It's not like Agile, where we have a manifesto where it's clearly defined what DevOps is. It means different things to different people. So, there's things like DevOps tools, there's job titles like DevOps engineers. So I did a predictive search on Google, and I got some interesting results. Right, is DevOps for hipsters? That's quite interesting. Probably should have grown my beard. But quite interestingly, the answer to all those questions is no, right? So to try and explain DevOps in one side at a high level, it's an ideas or set of ideals, new and old, which has led to a common set of practices and patterns. And the goal of my talk today is to share some of these ideas, practices, and patterns. And a disclaimer from myself is that I'm looking at DevOps from a developer perspective. If I was sitting in the audience, what kind of things would I want to be hearing about? I'm also keen to have a discussion around these ideas, and I'm here the whole weekend, so if you want to come chat a bit more about DevOps, find me and we can grab a beer and discuss these things. For those that do want a definition, there's a definition that was coined by Damien Edwards and John Willis, which is the CAMS definition, and the first bit is C, which stands for culture. People are the essence of what DevOps is about. It's the understanding that software is built by people, for people, and it steals a bit from Agile, where it's interactions and individuals over tools and process. The second bit is automation. A DevOps implementation relies heavily on automation, and it's about automating everything. It's about automating your builds, automating your infrastructure, automating your testing, automating your deployment. And I'll talk quite a bit about this today. Then it's measurement. The idea around measurement is that we measure everything that's important to the business, and those metrics and measurements are prominently displayed within the organization. If you've ever been in a DevOps culture, you'll see big dashboards up where there's monitoring and metrics where people can have open communication about a lot of different things. And then the last bit is sharing, kind of like I'm sharing these ideas today, but it's about sharing ideas, sharing tools, and sharing processes. So why do we need DevOps anyway? Well, the 2014 State of DevOps report was a report that was commissioned by ThoughtWorks, Puppet Labs, and IT Revolution Press. It was really interesting. They surveyed something like 9,200 organizations. It's the largest and most comprehensive DevOps study to date. It's also the first scientific study of the relationship between organizational performance, IT performance, and DevOps practices. But the executive summary of the report had some interesting facts. So, strong IT performance is a competitive advantage. This is more the business side of things, but they found that people that were implementing DevOps were twice as likely to increase their market share, their profitability, and productivity. But the second point really caught my eye, and that is there's a strong correlation between DevOps practices and IT performance. And this is kind of key, because people have been bashing on about what DevOps is about, these DevOps ideas, but now we actually have some proof that these practices and stuff actually have a direct correlation to IT performance. I've put the link up there to the report. It's definitely worth having a read. And the report also said that people that organizations that implement DevOps just keep on getting better and better. And I saw a talk recently by Gene Kim. For those of you that don't know Gene Kim, he's the author of the Phoenix Project. He's been studying high-performance IT organizations for close on about 13 years. But he said something in one of his talks that's really stuck with me, and that's that the best just keep getting better and accelerating away from the herd. So what this means is that people that are doing DevOps practices, those IT organizations are really able to move forward and pull away from the competition. Okay, so I'll let you read that quote quickly. So when I put this talk together, I really struggled to put into my own words why DevOps is important. And I stumbled upon this quote, and it really sums up things quite well. Because in a DevOps environment, the developer mindset has to change. There has to be an understanding from developers that software is a thing that exists after it has been written. So your software needs to live somewhere, on server somewhere. Once it's finished on your desktop, is it actually finished? Developers need to change their mindset and start thinking about how we're going to deploy our code, right? How are we going to monitor the application in a production environment? Is this code going to work in a multi-node environment? The developer mindset really has to change. We have to start thinking about these operational things, these infrastructure things. Okay, so if you've ever seen any talks on DevOps, you commonly hear about the silos within organization and the idea that we need to break these silos down. But why? Okay, because in a lot of organizations, a company is separated by division of labor. So what you have is a development team, where I've made it up here of developers, QAs, and testers, and then you have another team which is an operations team, right? And generally the development team strive for change, right? And operations strive for stability. So what you have is you have this misalignment which leads to conflict within organizations. Because developers want to get their changes live, but operations are pushing back and saying no. Also, development is measured on things like features, where operations is measured on things like uptime. So breaking down the silos. So something that's key to the DevOps movement is that ideally no isolated silos exist in the software delivery process, right? And a lot of people, to try and solve this problem, they form a DevOps team, right? Which is quite an ironic way to solve the problem, because essentially you end up creating a third silo, right? You end up creating a third silo. So if we could create a DevOps team, that would be great. But that's not what DevOps is about. It's not about creating a separate team between operations and developers. DevOps addresses the dysfunction that results from these organizations composed of functional silos, right? And it proposes instead strategies to create better collaboration between functional silos, or doing away with functional silos altogether and creating cross-functional teams. So what that means is developers and operations aren't two separate departments. They're working closely together to solve problems. Also, DevOps proposes shared responsibilities and incentives across teams. So instead of rewarding developers for features and rewarding operations guys for uptime, there's an understanding that everyone's working towards a common goal. And that common goal is to ship software to our customers that has value for customers. Okay, the other key thing to understand is that DevOps is a cultural shift. Okay, so to explain culture is the behavior of humans within an organization and the meaning that people attach to those behaviors, right? And in the DevOps 2014 report, they did something really interesting. They tried to measure culture quantitatively, but they used a topology of organizational culture developed by Ron Westrom, who's a sociologist from America, who breaks up behaviors and organizational culture into three different areas. The first is pathological, which is power-orientated. The second is bureaucratic, which is rule-orientated. And the third is generative, which is performance-orientated. Okay, so the first type of culture, a lot of you might recognize. So in a pathological culture, there's very much a them versus us culture, right? Developers and operations are at war with one another. They don't play nicely. Developers are just lobbing untested code over the wall. Operations can deal with it now. It's their problem. The operations guy, kind of like in the picture, deploys the code, production blows up, and he ends up getting fired. Meanwhile, it's the developer's fault. Not uncommon. And, in this environment, there's actually really a human cost, right? People feel a lot of the time you feel helpless and trapped. It's the kind of environment that if you've worked in, you don't get up and look forward to going to work. The second type of environment is bureaucratic and rule-orientated, right? So in this type of environment, you can move along at sort of a predictable pace, but the complexity within your environment is managed by process and centralized decision-making. So before we do a release of software, we kind of have to maybe get it signed off by someone. In this type of environment, there's sort of a steady throughput, but like people aren't looking to innovate and sort of play with new ideas and try new things. It's very bureaucratic, essentially. And in this type of environment, people will generally feel frustrated and they don't feel empowered. So the third type of culture, which is generative, is quite correlated to how a DevOps culture will be within an IT business, right? And the thing is that there's strong collaboration between developers and operations to reduce risk on things like deployment and solving the hard problems. People are trying new ideas, innovating, trying to solve the hard problems together. And in this kind of environment, people really feel empowered and like they can move forward and move a lot quicker. But the thing I want you to take away from today's talk is that DevOps identifies that organizational culture is important, and this culture is crucial to whether or not DevOps will succeed within any organization. So the next time you hear the word DevOps, think about the culture where you work in, how you want to change that culture and move your organization forward. Okay, so the third thing I want to talk about is how do we increase collaboration between Dev and Ops? Okay, this is a great quote from Patrick Debois, who's the godfather of DevOps, who coined the phrase DevOps. But what is remarkable is that even though Agile actively seeks collaboration from all its stakeholders, most Agile projects did not extend themselves towards the operations people. So what does this mean? We end up in an environment which is commonly referred to as Scrum Fall, right? Where you have an Agile development team that have optimized themselves, that are developing software in an Agile way in increments, but the process ends when they release the software to sort of test environments, or sometimes as far up as production. And then what you have is a waterfall operations team that the first time they interact with the release is when that software needs to be deployed to production. And what generally happens is that the software can be of good quality, but the developers have spent all the time in the schedule developing features, and because of time pressures now, the software has to go live. There's quite a dependence on operations because they've now got to deploy the software, and it again ends up causing more conflict. So how do we change this, and how do we solve this problem? Well, a key idea within DevOps is to change your definition of done. Okay, so at the end of each sprint, we must have working and shippable code. Okay. Demonstrated in an environment that resembles production. So the next time you start a new project and it's Agile, think about it. At the end of sprint 1, you want to be able to deploy that software to an environment that resembles production. Because what this does is it starts to surface your non-functional requirements. You start to think about, what version of PHP are you going to be using, where your software is actually going to live. Secondly, there's another practice, which is make environments early in the development process. What's key about this is that there's some great tools for this. A lot of you have probably heard of Vagrant or things like Docker, right? But the idea with making development environments early in the development process is that developers are developing locally on an environment that resembles the production environment. And the reason for this is that it reduces dev-prod parity. So we're using the same version of PHP locally than as production, but also it solves that problem of, it works on my machine. So The second thing is to make sure Dev and Ops build code and environments at the same time. Kind of like our software evolves, so should the environments that our code runs in. So, if you add messaging to your application, don't just install the messaging queue locally on your laptop. Also make sure that messaging queue is available in your environments. All right? And the way we do this is with configuration management tools, infrastructure as code, otherwise known, because a lot of our applications are running in virtualized environments. I've put some cloud providers there, Amazon, DigitalOcean, and Rackspace. But ideally what we're doing is we're using tools like Chef and Puppet and Ansible to manage the servers, the virtualized infrastructure. Right? And what that allows us to do is it allows our environments to evolve as our software evolves. So we've got a version of environments and a version of software that are aligned with one another. A lot of the time in a lot of organizations, people aren't using these tools and they still have Snowflake servers. And you've got a system administrator logging in and creating these snowflakes where he's making changes. And the environment where your code is being deployed to is continually changing. And so, it's trying to marry those two up and keep things, the same. So these tools enable more transparency at the infrastructure level. And what this means is this is where developers can come in and start to contribute to the environments that their code runs in. Because you can contribute to writing some Chef scripts or Puppet scripts and change your environment. So if you want to upgrade the version of PHP, it doesn't become a task downstream by someone else. You can actually make that change. But the great thing about these tools is that it also gets developers and operations people collaborating early in the software development process. And so what's key to understand is that there's a lot of these sysadmins that come from a background where these tools didn't exist. And the key here is that developers can help sysadmins learn to write code and to better manage infrastructure. So that's a key area where developers and operations can collaborate. Okay, so create a common dev, QA, and production environment process. There's a really neat tool called Packer. So Packer is a tool for creating identical machine images for multiple platforms from a single source configuration. So if you are using Chef or Puppet or any of those tools in your environment, you can use Packer to create a machine image. And that image can be an AMI that you can deploy in Amazon, but then you can also generate a box file so that developers can use that environment for the development environment. But there should be a common way that dev, QA, and production environments are created. Some other practices are that collaboration between development and operations starts before the development of software and well afterwards. So that Scrumful where I showed you where it was developers and then, okay, now we've got to push this live. Ideally you start collaborating at sprint 1. So when you start building your software, the operations guys are, building the infrastructure and things are evolving together. And also get operations and developers sitting together. Now that sounds really stupid or obvious, but the idea is you start to foster relationships with your operations people and you can sit together and collaborate on different problems. But also just some of the conversations that developers have at their desks. A lot of the time an operations person will overhear that and come and ask and try and contribute to solving that problem. And it gets the discussion and it starts this idea of open communication. Okay. So, I've talked about a couple of things. I've talked about breaking down the silos. I've talked about understanding your culture. I've spoken about how to get developers and operations working better together. What's the next key idea? It's the idea of cycle time, right? And to easily explain cycle time, it is how long does it take you to go from code committed to getting that code running in production? And if I said that in another way, if you had a critical bug fix, and it was one line of code, how long does it take you to get that code to production? What if that critical bug fix is costing your business money? Right? Looking at it from a business perspective, this is a great code. What business really want from us as software developers is that we allow them to have an idea, get the idea in the hands of our users, figure out if the idea works, and react to the understanding that we gain from this experiment. In the Devops 2013 report, there was something that really blew my mind. There was a key finding, and that was that high-performing organizations deploy code 30 times more often and 8,000 times faster than their peers, deploying multiple times a day versus an average of once a month. Secondly, they have 50% fewer failures and restore services 12 times faster than their peers, right? But this generally isn't the reality for a lot of us as software developers, right? Some problems dev and ops teams face is that cycle time is measured in weeks or months. So we write code today, but actually it only goes live 2 months from now. And there's a real opportunity cost on that, right? Because that software might be really valuable, might be a really valuable feature to the organization, but that value only gets realized in 2 months' time. The second thing is we have problems with deployment. It's not a reliable and a repeatable process. You know, a lot of the times for people nowadays, even in 2015, deployment is still manual. You know, doing a git clone on a production server. But the idea is that there are a lot of problems around deployment, and deployment for a lot of people becomes a scary time because there's an element of risk involved. So people are actually just scared to deploy code because things can go wrong. And the third idea is that there's various bottlenecks within an organization. So sometimes it's, you know, the responsibility of the senior developer to release the code, or to release our code, we're dependent on, you know, operations people, or we maybe even have a release team within our company that slow down the whole process. So how do we solve these problems? All right. Firstly, one of the key goals of DevOps is to increase flow, reduce cycle time, and shorten the feedback loop from the time that we write the software and get that software to production. So to solve those problems, a lot of the stuff that's been adopted within DevOps is continuous delivery. Okay, how many people have read this book? Wow, okay. I thought it would be a bit more than that. If you haven't read this book, it's a book that every software developer should read and try and implement some of these practices. So for those of you that don't know what continuous delivery is, it's a design practice using software development to automate and improve the process of software delivery. You know, using techniques like automated testing, continuous integration, and continuous deployment, with the key goal that software can be developed to a high standard and easily packaged and deployed to environments, resulting in the ability to rapidly, reliably, and repeatedly push out enhancements and bug fixes to customers at low risk with minimal manual overhead. Right? I mean, that's the definition taken off Wikipedia. But people practicing continuous delivery, there's some key goals of continuous delivery, right? And that is software is always in a releasable state throughout its life cycle. So it's making sure that our software is always in a releasable state. And this is quite a paradigm shift for a lot of developers and a lot of people. Secondly, a lot of people practicing continuous delivery say the only way to categorically prove that software is production ready is to deploy it to production. When you get real users on your software, when you've got 1,000 or 10,000 people actually using your software, that's when you can say this software actually works and does what it's supposed to. Okay, so this is quite a key slide in my presentation. Right? So what's key to understand here is that when you choose small releases over big releases, you get the same amount of functionality over time, except that the business can realize the value a lot quicker, right? So over here, we're doing sort of these big bang releases where we've got a whole big feature set, right? But in the yellow bit, we're doing small releases over time, right? And that's kind of key, because there's benefits of deploying more frequently, right? The first being that smaller changes make it easier to identify problems. So when you deploy only one feature to production at a time and something goes wrong, generally you can identify the problem a lot quicker. What that also means is that a lot of the time, instead of rolling the feature out and fixing it, a lot of the time it's quicker just to fix the problem and roll forward just one step more. Right? Also, the risk of deployment is reduced, right? The reason is, the idea is that because you're practicing deployment over and over, right, there's a big incentive to make sure that deployment works. You know, that notion of if things are painful, do it more often. And the process of fixing problems becomes optimized, right? So when things do go wrong, we work out ways to quickly resolve those problems. So those are some key ideas behind continuous delivery. So eventually, deployment becomes a non-event. It becomes even a boring, straightforward process that actually frees up developers and operations teams to go about doing other things and doing other work, and they can just deploy their code and not worry about it. Right? So to move towards continuous delivery, you need to understand a bit about continuous integration. Now, continuous integration, explained very simply, is that every commit you do to your code, right, triggers off a comprehensive set of tests that builds the application. But the idea, too, with continuous integration is that we keep software in a workable state, right? And we create quality at the source. So what that means with developers that are practicing continuous integration is they are looking to build quality software, right? And this is key because it helps build trust between operations and developers, right? And trust is a big part about what DevOps is about, because operations can trust that developers are doing the right thing. Not only that, quality is not only the job of developers, it's the job of everyone in the team. So everyone's looking to create quality software. So it's a real cultural change within the team, right? Fix broken builds immediately. So if you are practicing continuous integration, the idea of this is that you don't block other developers. I've worked in a lot of environments where the build goes red, and like developers just don't react, right? And so I like to use the analogy of if you were sitting here right now and a fire alarm went off, are we all just going to sit here and I'm going to carry on my talk? No, we're going to run out the building, right? You react quickly, and that's the idea with continuous integration. Don't block other developers. You know, when a build breaks, it means your software is not in a workable state. Fix it, inquire what went wrong, put another test in place, fix the broken test. Don't leave broken builds, there forever, because you actually are blocking other developers in, because the worst thing you can actually do is check in onto broken code. Also, keep your builds fast, right? You want to get feedback sooner. Right? So what generally happens on projects is you started with a continuous integration, and then 3 months later, down the line, the builds are taking 10 or 20 minutes, and then, developers take longer and longer to get feedback. By the time the build breaks after 18 minutes, the developers switch context, and now they've got to come back to looking at the build. So the key idea is, my slides aren't, oh, it's back, okay, cool. The key idea is to keep your builds, fast, so you get feedback sooner, right? Automated acceptance testing is another key idea within the DevOps space, but to do with continuous delivery, right? And that's because automated acceptance testing acts as your safety net when you deploy often. If you can validate that your business-critical features of your software work, why can't you deploy it? Okay, my software works, let's ship it out. Right? And there's a guy from Google had a quote, automated testing turns fear into boredom, right? And it's kind of true. It gives developers so much confidence. I worked in a high-traffic environment with a website over a 3-month period where it was kind of a campaign, and we took thousands and thousands of pounds. And we had an automated test suite that took 12 minutes to run. And what it did was it tested all the critical parts of our application. It tested, could users register? Could they make a donation? Could they do certain things? We really just cared about the critical path. And when we could validate in that 12 minutes that almost all our features were working, it gives you great confidence to just ship your software. But if you don't have automated tests, you're kind of taking potshots in the dark. So automated testing is very key. But when we talk about automated testing in a DevOps environment, it's not only about testing your software, right? It's about testing your non-functional requirements too. And non-functional requirements are things like capacity and performance and security. But some tools in this space, if you're using things like Puppet and Chef to configure your servers, I'm not sure if any of you have seen RSpec, but it allows you to write automated tests for your servers, and those are really really great tools. So I put the GitHub link there, you can check that out. Okay, so the last thing I wanted to talk about is a deployment pipeline. Okay, so a deployment pipeline is an automated implementation of your application's build, deploy, and test and release process, right? The thing is with deployment pipelines, they're obviously, I meant to say a lot of the time they're bespoke depending on the type of organization you work in. But the rules that govern the deployment pipeline, don't vary, right? So your deployment pipeline usually looks something like this. You have a delivery team that are checking changes into version control, right? That checking triggers your build and unit tests, and then developers get some feedback, right? That also then triggers off some automated acceptance tests, And then again, developers get some feedback. The key idea here is that as we go from left to right, you can add more of these steps. Your pipeline will be dependent on your type of organization and the software you're building. But the key idea is we get more confidence as we go from left to right that our software is in a shippable state. But obviously the tests, things like automated acceptance tests, generally will take longer to run than just some basic unit tests that are running on your code base. But the idea at the end is that we get approval and then we can push a release out, right? And so the idea is that at the end of a deployment pipeline, we can do a release. Now what's really interesting is that a lot of developers will do continuous integration, but they're only halfway there. They don't build a deployment pipeline, right? And the reason they don't is because it's generally a resource-intensive process. It takes time to build a deployment pipeline. The key idea is this is where you get operations guys involved because they generally have a good understanding of how to deploy code, and developers and operations can work together to build a deployment pipeline. Right? So some tools in the PHP space, before I get to that, some key objectives of a deployment pipeline, right? The first is collaboration, because the deployment pipeline is visible, the process of, building and testing and releasing your software is visible to everyone, not only developers and operations, but potentially, anyone within the organization, right? Is that we get feedback, is our software in a workable state? Is it in a broken state? Oh, the build's red, okay, there's something wrong with the software, right? And that feedback starts with these discussions and gets people collaborating. But ideally, teams can deploy and release any version of their software to any environment at will through a fully automated process. Okay. So some tools in this space. I've just literally cut and paste some tools onto the slide. I think the key thing is that as PHP developers, we have great tools available to us to build a deployment pipeline. Right? If you don't have a deployment pipeline, it's key that you invest time and you start thinking about building one, because it allows you to go from code committed to being able to release that software to any environment and makes our lives as developers a lot easier. Right? So I've spoken a lot about automated stuff. The last thing is automated deployments. Right? So the way to think of automated deployment is for humans is a two-step process. Right? The first step is that you select an environment where we want our software to go, and the second step is that we push a button to release the software to that environment. Right? So we don't have the bottleneck of somebody else that has the responsibility of deploying code. Actually, if you're releasing small features, anyone can push that button. Some big software companies like the Googles and the Facebook, developers on their first day, do a release. But the idea, if it's automated, essentially, once you've built that feature, you can just push a button and release it out. Deployment should never be a manual thing. It should never be a thing where there's a step of, steps that we need to deploy our software, because I think it might be familiar to developers. What ends up happening is you do a deployment and something doesn't go quite right, so you quickly change the process, right? And then you only deploy again in a month's time. And then the next person that deploys maybe doesn't know about that thing that you did, and then the software, sort of breaks again. So it's key that you automate your deployments. And this the automation bit is where the A in the CAMS definition comes in. Okay. So some tools for deployment. I've got for PHP, I've got Capistrano, Rocketeer, and Deployer. They are great tools. If you go onto GitHub or if you just do a Google search for PHP deployment tools, there's great tools out there that are built that can automate your deployments for you. And so you should really be thinking about, investing in some time in understanding these tools and using them to deploy your software. Okay, so the next thing I want to talk about is measurement. So the idea from this picture is, in a DevOps environment, you can see that key metrics and monitoring stuff is displayed to everyone, right? But the idea with monitoring that is that if you're moving, you're releasing software often, you want fast feedback. So you want monitoring in place so that when things do go wrong, you can go, look back at your data that you have and work out, what went wrong. So you want to be proactive about your monitoring, not reactive. So when something goes wrong, it would be great if we had, what the memory usage on the server was at that time. Be proactive about your monitoring. Add monitoring to the definition of done of new software features. That's a key idea within DevOps. Patrick Debois came up with this thing which didn't really catch on, which was monitoring-driven development. which is you write the monitoring for the software before you develop it. But don't think of monitoring as a task that's something that happens downstream. Someone else's job. Get involved. Go have the discussion with the ops guy. Ask him what he is monitoring. And then you can look to improve on that. The next thing is measurement, right? And in DevOps, it's kind of really simple, but you can't improve what you can't measure. So, if your deployments are manual, and then you move to an automated deployment process, you can measure that because you've gone from manual to automated. But then if your automated deployment process is taking, 10 minutes, the idea is that you benchmark that and then look to measure and improve, so maybe get it down to 5 minutes, or whatever it may be. But the key idea is that measurements are shared not only between developers and ops people, but with the entire organization. So that's really a key idea within a DevOps environment. And you commonly see in a DevOps environment these dashboards where everyone can see what's going on. And so when there's a massive spike on a graph, people can react to that. And it's not like, all your customers are phoning you up and say, hey, your software's not working. Because that's the worst kind of position to be in, is that we want to know about it before our customers do. Right? And some tools for monitoring stuff. I've chuck some on the slide. A lot of these tools are open source, for application metric, things like StatsD and Graphite, monitoring and alerting. Sensu's kind of, I wouldn't say the new kid on the block, but it's kind of, it's really a great tool. You can write custom checks. It's written in Ruby, but it's a really nice monitoring tool worth checking out. Log files from production. A lot of the time we've got application logs, but we can figure out so much about our application if we have a way of viewing those application logs. And so, there's the ELK stack, which is Logstash, Elasticsearch, and Kibana. So Logstash will generally ship your logs to Elasticsearch, and Kibana is a search interface and an interface to build metrics around your logs. And I've chucked Greylog and Splunk on there. Those are, I think, paid-for tools. But the idea is that there are great tools in this space, and as developers, we should be looking at these tools and working with our ops guys to put some of these in place. The last thing I wanted to talk about is sharing, which is a key aspect of DevOps, right? And that's about sharing the pain, right? And these are maybe quite controversial ideas for developers, but that developers take more ownership and responsibility for their code. This is a true story. I really recently spoke to a guy who was working in a company where they wanted to implement continuous delivery, and they proposed these ideas to software developers, and a lot of them left, right? Which kind of says a lot, because what do they know about their code that we don't? So that was was quite profound when he said that to me. But also, developers on call for production issues, right? I was a developer on a software project where one day someone said, "Well, can you go on call for the software?" Right? And then that got me thinking about, okay, cool. So if something goes wrong, it's my job to fix it. But how do I fix it, right? And so what it gets you doing as a developer is you start to think about how operations people and other people can, support your code. And if you do decide to do this, you start to build a common set of tools that developers and operations can use to support, production. Fairly controversial for some developers, but, I think the key thing here is that it helps you build empathy for operations people. Empathy is a big sort of thing. People in the DevOps circles are talking about empathy a lot, and that's what it's come to, is that just developers understanding that code that you write, it's also your responsibility, and it helps you develop empathy for those operations people. And then blameless postmortems. Right? Blameless postmortems are a key idea within the DevOps space, in that when things do go wrong, don't look to always blame someone else and point the finger, right? I've done one or two postmortem things where ideally you come up with a timeline of events on what went wrong, and you have an adult discussion about what went wrong and what countermeasures you can put in place to stop that happening again, because that helps you improve. But blameless postmortems are a key idea within DevOps to, when things do go wrong, look to put measures in place to fix things. Okay, so the other bits about sharing that I wanted to mention, I'll let you read that code quickly. So that tweet popped up into my timeline recently. But a key thing with source control within a DevOps environment is that a lot of the time when you think about your application code, you think about just the code that should be in version control. But there's a couple of other aspects, right? There's code and scripts for building the application. So if you are using something like Jenkins, those code and scripts are inside the application because that allows people to share and work on that together. Code and scripts for testing the application should be part of your repo. Code and scripts for deploying the application. So whatever you're using to deploy the application, a lot of the time can be made part of the repo, which is key. And then code and scripts for building environments for the application. So if you are using things like Chef and Puppet, you are writing code, those things should also be versioned. But it also allows developers and operations people to contribute and share and to use a common tool set for the software delivery process and for the things that you're building. Okay. I think I kind of whizzed through that. But in summary, what have I spoken about today? I've spoken about why we need DevOps. We've actually got some proof now that DevOps, does increase IT performance. There's a large, scientific study. I've spoken about breaking down these silos, these, cross-functional teams. There's no division of labor. I've spoken about organizational culture and why that's important. Are you in an environment where everyone's just blaming one another, or are you looking to work together and solve problems together? But it's key when you think about DevOps to understand what your organizational culture is and how you move that forward, especially in larger organizations, because culture in those organizations a lot of the time is pathological and bureaucratic, and so you might not be able to get DevOps right in those type of environments. I've spoken about increasing collaboration between developers and operations and some ideas there. I've spoken about cycle time and continuous delivery and why cycle time is a vital metric for most businesses. I've spoken a bit about measurement and monitoring and sharing. But I wanted to leave you with this parting thought, right? On the 5th anniversary of DevOps, Patrick Debois, the godfather, said something, right? DevOps gave the industry a hint of what it could become. It's now up to the industry to make it happen or stubbornly stay the same. Okay, that's it, really. So thanks very much.
Okay. Yep, we're on. All right, so question time, I guess. You want to take some questions? Yeah. All right, we'll start over.
On your diagram where you had a deployment pipeline, you talked about getting feedback quickly. What would you say is a good kind of time frame where you expect to get feedback? What would you be happy with, and what would you start to say, it's getting too long now?
It's a fairly good question. It obviously depends on the software you're building. I think for me, I want feedback as fast as I can. So, you want to try and, shorten that feedback loop. I've been actually doing a lot of reading lately about how to shorten that, feedback loop. I mean, it's really hard to say. I would say, it really depends on the software application. If you've got a monolithic application that has got a lot of features, it might be impossible to really make a short feedback loop. But I guess because I've worked a lot in continuous integration environments, you kind of just, when you watch the build running, even if you just and you see like a test standing there, and you can visibly count, it's taking 1-2 seconds, investigate why, and try and shorten that feedback loop. But to give an exact time measurement is really, really hard. I think I didn't talk about it much, but there's some key ideas in DevOps about making your builds faster. So if you are using Jenkins, like using things like multiple slaves, so parallelization to make builds faster. PHP doesn't have concurrency, so I've played around with a paratest, which can run PHP unit tests in parallel. I've had some, some wins there. Other key things, other tools. Yeah, I mean, PHP doesn't have a concurrency model built in. So, but yeah, it is a key challenge of trying to make your build fast isn't straightforward.
I think also monitor them, graph them.
Yeah, I mean, that's the other thing too, yeah. So you can use something like, Stats or Graphite, you can use timing metrics. So, I mean, that's the other way to do it. You have a timing metric to graph how long the build is taking. And then as you start to see it go up, look to sort of reduce the time.
To the other room. Aaron?
Hey, it's not really so much of a question as a comment. You were talked in one of the final slides about making sure you commit into version control the tests and scripts for deployment, testing, etc. And you mentioned that about the application, but one thing that you didn't do is that you also need to commit the tests, specifically the tests for your environment, as well as the tests for your application.
Yeah.
And that's really important because if you've got from an operations side point, which is what I am, if you can test your environment before you're putting the code into it, it helps you, it means you can change, you can upgrade, and you can improve the environment so you're in a better place before you run the application and the tests on your new environment. And I thought that's important to feedback from an operations point of view as well.
Yeah, that's really key. That's a good opinion. I totally agree with that. So it's kind of weird when someone else is in another room. Any more questions?
You got any more, Aaron?
No, none in here.
Okay, cool. Well, I am here the whole weekend, so if you want to come grab me and ask me a question, I'll be at the social tonight and we can discuss more about DevOps and some of these ideas. Thanks very much.
Thanks, Aaron. Cheers.